Hello, Morenci! Welding students this time. So today we're going to be doing a sketch of the upcoming gate project. So we're going to go ahead and be making gates today or in the future, and we're going to make our sketches for those gates right now. So first thing to know is that the gate is essentially a square made out of 1-inch square tubing. So we're going to go ahead and draw a square here. Actually, it's not quite a square. What it really is a rectangle that is almost a square. So our rectangle is going to be 34 inches by 32. Actually, I think this is a side view at this point. But anyway, 32 inches by 34 inches. We're making a 1-inch square tubing. So let's go ahead and represent that here. Okay, there we go. And one more here. And you're going to cut your square tubing so that it has these nice mitered corners here, these 45-degree mitered corners. So you're going to need 2 lengths. At 32 inches and 2 lengths at 34 inches. So from here, this is your frame. From here, we can go ahead and start putting stuff in. Now, there are a couple options for what you can put in here. We have a bunch of stuff out in the scrapyard, and making a scrapyard gate is perfectly acceptable. We also happen to have a bunch of material that can be turned into sort of an Art Deco thing, so if you have an actual art theme you'd like to try, we can probably come up with a way to achieve that. I'm a fan of Art Deco for this project simply because it involves lots of nice linear design, which is really easy to make with steel. So we could do things like this with that Art Deco, and then come over here a bit with some more square tubing. Maybe do something along this lines, come over here and do this again, repeat this, or come in with, I don't know, we could come in on the same angle here. Anyway, so we're just going to start randomly coming up with a few interesting ideas. You probably want to draw a couple of these just to sort of get the general idea of what this is going to look like or what you would like to achieve here. And then we'll actually go out into the shop and come up with something. So here are a couple of interesting ideas. We could go ahead and maybe toss a circle in here. This is a tricky thing to do, but it is something that you could do. We can bend a circle with 1-inch square tubing. Not easily, but it's doable. So we could come up with something like that. We could also use flat stock or strap or something like that to achieve the same look. Might be able to do something with pipe, who knows. So a couple of different interesting ideas here. Now it is going to be important that we go ahead and find out exactly how much steel we need to order for this project. And we've walked through this once or twice before, but we're going to go ahead and do that again here, just so everyone is clear how much steel we need to order, so when I go and talk to the principal, we know how much we're buying. So let's go ahead and finish this design off real quick, and then we'll walk through that math just so everybody knows what's going on. We should probably put something here. But for the project, each student is going to need 32, 34, 2 lengths at 32, and 2 lengths at 34. Times 2, 2, and that's going to come out to let's see, 64 inches of steel there, and let's see, 68 inches of steel here. So we've got that. Per student. Notice I'm keeping our units here. So 64 and 68, 64 plus 68 is going to equal 132 inches. I've already done this math. This is what I know. Inches, inches, inches per student. And if we divide 132 by 12 inches, what we're going to find is that this equals 11 feet per student. So we need 11 feet per student. Now, I've looked at my class rosters, and it looks like I've got, let's see, 9 students in the first hour, 9 students in the third hour, and I want to say 10 students in fourth hour. So that's going to be, let's see, 18 plus 10, 28 students. Yeah. And each one of those is going to require 8 feet, or 11 feet. First, second, or third, and fourth. 28 students. So now we're going to go ahead and multiply 28 students times 11 feet. And at this point I need to pull out the calculator. 11 times 28. Let's try it again. 11 times 28. It's going to be 308 feet of steel. For all of my classes. Now, 308 feet of steel is okay, but steel comes in 20-foot lengths. We need to divide this number by 20. 308 divided by 20 feet. It'll give us 15.4 length steel, which means I'm going to actually order 16 lengths of steel. Round up when you're ordering. Okay, and actually what I'm going to do is I'm going to multiply 16 by 1.25. 16 times 1.25. 1.25 will take this number and add 25% to it to come up with 20 lengths of steel total. Sorry. And this will give us a little bit of wiggle room for extra students or artistic uses, whatever. We're going to order 20 lengths of steel for this project. Now, I went ahead and went to ACE today and found out that our 1 inch, let's see if I can find it here, hollow square iron, 16 gauge, $20 per length, or essentially $1 per foot. So I need 20 lengths times 20, going to equal $400 for this whole project. So let's see, we'll zip over here, 20 times, oh actually I should do this correctly, 20 times 20.84 is going to equal 20.84 is going to equal lengths dollars is going to equal $416.80 for the whole project. Now we can go ahead and divide this number by the number of students to figure out what this is going to cost per student. And it comes out to 14 bucks, essentially $15 with if we round up from the change. It'll actually come out to $14.88 per student. All right. So we're going to run through this math. Actually, we've already run through this math. I'm showing you this math. This gate here happens to be the size of a standard chain link fence. So if you have a standard chain link fence, you can use these measurements to create a gate that will fit in your fence. Check things, of course, to be positive. But 34 inches should give you the right size. Then you come up with whatever you want for the inside. Again, I went with an Art Deco. It seems to work out pretty well. Spend a few minutes online looking at various art forms, steel gates, things like that to get some inspiration, and you should be able to come up with a pretty cool idea that we might even be able to do. Now, a couple of no-nos. Things not to do. Don't do. No names. No sports teams. No numbers. Unless you happen to live at, say, 110 Mariposa and you put 110 on the gate. So if this gate is going to go sit at a specific address, go and put that address on. But you won't be able to move the gate to your new house if you should move, because your addresses probably won't match up. So no numbers. Let's see, no names, no sports teams, no numbers. I'm going to say no letters either. This is sort of along the same idea as the no numbers and no sports teams and no names. Basically, if you should move away from this house and leave the gate in place, you want the next people who move in to be able to use that gate and not, say, hate it. So we want this to be usable by multiple people, including yourself. So no names, no sports teams, no numbers, no letters. There may be a few extra rules here. And of course, if you are on YouTube and not one of my students and you want to go ahead and make this project, then by all means, do whatever you want. Alright, and that's about it. If you happen to like this general idea, the math, the gate, the project itself, we'll have additional videos probably located in this area. You should, of course, like and subscribe over here. And that's about it. Thank you very much and have a great day.